I need a haircut. About 10 years ago, when I told the folks back home I was moving to Hobart, Tasmania, they said, wear the fox hat. Right, everybody, g'day, welcome back onto Basket Case. So it's back from the mainland, been back a couple of weeks now. I'm finally getting an opportunity today to start having a look at what has gone wrong. My objective today is simply to diagnose what component failures I've got, if any, and that way I can start thinking about what I need to purchase and which direction I'm going to go. I've got a hypothesis on what may have happened. We need to look at the evidence before us. I run a lithium-ion battery. I dropped the bike in Campbelltown. These are the things that we know, whether they had an impact or not. We had 2 really hot days over 45 degrees Celsius. The ignition cut off completely and the battery voltage is at 0. So there's a couple of things. The XS1100 is a battery powered ignition, which means that it gets its ignition power from the battery, not from the alternator or some sort of coil that's being used just to feed the ignition. It gets it directly from the battery, and it requires, I think it's a minimum of 10.5 volts to fire the transistors that fire the coils. That's the other thing, we lost a coil. When it broke down on the side of the road, I restarted the bike and it ran on 4 cylinders on the side of the road. When we transported it back to Balan, it would only run on 2 cylinders. Now, those 2 cylinders were cylinders 1 and 4. 2 and 3 wouldn't fire. So I did a quick test on the side of the road. I thought maybe it's a failed coil. I swapped the plugs over. Still no different, would only fire on coil cylinders 1 and 4. And then I swapped all the leads and everything over. So essentially what I did was I replaced the coil that was firing with the coil that wasn't firing, and the coil that wasn't firing fired, and the coil that wasn't firing didn't fire. So my belief is that what I think has happened, without wanting to predict too much, something has failed in the charging system. Now, there's not many components in the charging system. There's an alternator and there's a regulator rectifier. Lithium-ion batteries have an overcharge protection in them, so that if they get to a certain level, if your alternator is putting out too much in, if your regulator rectifier fails and it overcharges, the battery goes into a safe mode and it essentially internally fuses, so it's kaput. What possibly could have happened is that is the likely scenario that I think, on reflection, that it's overcharged, the battery's gone into safe mode, that killed the ignition, and in doing so we've taken out the transistor that fires coil 2 and 3, so the coil for cylinders 2 and 3 in the TCI. That's my guess. The other possibility is we could have had a pulsar coil fail, so it's not actually telling TCI to open circuit the coil and generate a spark. So I can test that as well. And if with coil type windings, you can have a problem with high temperatures. If you have a break in the winding, it may not be evident in cooler temperatures because everything's all nice and tight, and then when it gets hot and it all starts to expand, then you end up with a break in your winding. That can happen. So it's possible that in the high temperatures of that day, if I did have a failure of the pulsar coil, it may have been presenting that day, but may have not self-healed, but cooled down enough that it functions again. which would be frustrating because we want to find out what happened. So enough waffle. Let's rip its skirt off and start delving in and see what we can find. Alrighty, got the old voltmeter set to volts. Let's just have a look what's going on with this battery. 2.86 volts. Well, the main fuse used to live here, so I better go and do something with that first. Then what I'll do is I'll pop another battery on here, replace the main fuse, and we'll see if we can start the bike and do some tests. Alright, fast forward. We've got an AGM battery hooked up. I've got a new fuse. What I want to do is see what the charge output is, if any, from the regulator rectifier to the batteria. So I'm going to jam, hopefully, these banana clips. Might use a snap-on one. Hopefully you can see that alright. 13.23 volts currently. Just turned on the juice. Indicator's going. Right. Put some petrol on. This bike has not started since it was in Melbourne, so God knows what's going to go on here. Zero volts, geez. 0 volts. Why is it 0 volts? Did it slip off of there? Yep. Whew. Too many volts. Too many volts, and it's only firing on 2 cylinders. We might just do a quick check of the pulsar coil. Okay, so what we're looking for here is continuity. A trick taught to me by Christian Wraith. Thank you, Christian. If you're wanting to test these pulsar, these are the pulsar coils here. I've removed the timing plate so we can see a bit better. You want to check first just by pulling on the wires to see if they haven't been broken. Now this wire here has been repaired. This blue and this pale blue wire, because it's got heat shrink on it. So that has been repaired at some stage. They're very, very soft and malleable wires. We want to check the continuity between here and the plug, which I've disconnected and I've got hanging here. Yeah, what Christian told me was if you put a pin, like a dressmaker's pin, into the wire, that'll save you scalping it back, and then you just put your clamp on the pin. The snap-on Vantage Pro, I've also got these very, very fine back probing pins. Just going to try and gently insert into there and come up to the plug. Alright, that one's okay. That one's okay. Alright, there is one other test that we can do on these pulsar coils, or pickup coils, if that's how you want to refer to them. We can change our meter to ohms, calibrate it. So the factory workshop manual says 720 ohms resistance through the pickup coils at 20 degrees Celsius. It's currently about 36 degrees Celsius in Hobart, so there'll be a little bit of discrepancy there. And there's also a tolerance of plus or minus 20%. So 720 ohms plus or minus 20%. Now I'm currently on 4,000 ohms, so it'll be in kilo ohms, so it'll be 0.7, because this thing doesn't have, it's only either 400 ohms range or up to 4,000 ohms range. So we choose that, and that'll put us in the kilo ohms, which means it'll be 0.72. It should be. So we take our plug, put our probes onto our units, and that pulsar coil is 780 ohms. We'll check the other one. They should be within 10% of each other anyway. 790 ohms. So the resistance in those pickup coils is fine. The continuity between the pickup coil and the plug is fine. That rules them out. Transistor controlled ignition unit. So my TCI is housed up underneath here, and that's what's crapped itself on tipping. So by a process of elimination, we know our pulsar coils have continuity. We know that so we don't have a broken wire there. We know that both of the coils work because I tested them on I swapped them over, and they both function, but not on that one trigger. And the only thing left is TCI. Well, we've pretty well diagnosed what's happened, and it's in line with my hypothesis. The regulator rectifier has failed on the regulator side. So for those that haven't been exposed to what a regulator rectifier is, after the 1970s, most of these bikes were a combined unit. Actually, I've got one. This is a regulator rectifier. Most of the bikes after the 1980s or after the 1970s had these. You have the 3 input wires from your alternator. So the alternator provides an alternating current, and the alternating current is a sinusoidal, just presents as a sinusoidal wave. So if you've got 0 volts as your line, it'll rise to, say, let's just arbitrarily say 12 volts positive, then it'll go 12 volts negative, and then 12 volts positive, and then 12 volts negative. Why does it do that? Because it's generated by a magnet. So you've got plus, minus, plus, minus, plus, minus as it rotates. So it's a push, pull, push, pull, push, pull system. And that was Tesla's baby. He was a big believer in alternating current, because you could reduce the size of the cable that you had to shoot it through by upping the voltage, and you're able to step that voltage down. Back in the day, there was no way of stepping down high voltage direct current, and that was Edison's baby. So Tesla worked for Edison. Tesla wanted to go AC. Thomas Edison, he didn't want to. He wanted to put direct current into homes and businesses all around the world. That was what he was hedging his bets on. He was going to be this giant of industry, providing direct current electricity via a series of little generators, in basically feeding only a couple of houses at a time, because he couldn't get the voltage high enough to transport it. Tesla knew better. Edison wouldn't listen. Why? Because he held all the patents for direct current. So him and Tesla had a falling out, and he ended up, long story short, working for Westinghouse, George Westinghouse, and they went ahead with alternating current. So here we have alternating current and direct current working in harmony. So we take that alternating current, that shunting, and block it with diodes so it can only go one way. That's what the rectifier side does. So it converts it from an alternating current into a direct current. You've got 3 of them feeding, 120 degrees out of sync, so that there's always one shoveling through. And then the regulator side provides a 12 volt output to your battery. And that's the side of it that's no good. I can't use this. It does have a battery and an earth, which output there. It's got the 3 alternator wires. The only problem is that the XS1100 has a field coil alternator. Wait. So instead of using permanent magnets that spin around a stator to generate the alternating current for the regulator rectifier to go and sort out and provide your battery, Yamaha went all out with the help of Toyota actually, and they put a field coil alternator. So this field coil is, as the name suggests, a electronic magnet, electromagnet. So it has a north and south pole as well, and these are the coil windings that provide the 3 alternating currents out to your rectifier, and the way that it reverses the polarity for this guy is this is stationary, but there is a rotating drum that has got wedges cut out in it, and actually I don't have one I can show you, but it looks like a welded mess. Basically, it looks like a squirrel cage, and that alternates the current. So that's a field coil type magnet, and this field coil is powered from the battery or from the ignition system, but the return, the earth, stays above earth, and it comes back through the regulator rectifier and is actually regulated. But that rec doesn't have that functionality, so I need to do something better. I'm waffling again. So my thoughts are, gut it. Get rid of the Yamaha ignition. Go for something like an Ignitec aftermarket ignition with a mappable ignition map, with a programmable ignition map. The only thing I might have to do there is somehow work out how to put a throttle position sensor on flat slide carburetors. So that could be a bit of a, I mean, it'll be doable, but it'll be a challenge. My friend Brian Horn, has an Ignitec system on his XS1100, the chain-driven converted one, and he said it changed the bike, absolutely changed the bike. And the aftermarket ignition systems, whether I go for an Ignitec or something else, replace all of the components. So they replace your pulsar coils, they usually have like a Hall effect sensor or something on a disc. They replace the igniter unit, they even replace the coils, everything. So it's a standalone ignition system. And then So, and maybe a solid state rec or cobble something together. I've got a couple of guys that I know that are very clever with that kind of thing that I might drag in. Anyway, it's all expensive and I don't have enough money to buy it at this stage. So I'm going to do some homework, do some research, do some shopping, and we'll come back with a solution. But in the meantime, like I said, we now know exactly what is wrong with basket case. It's not the end of the world. I mean, it's pretty terminal for the bike, but it's in terms of the ignition system. But we can work through it. Anyway, thanks for watching. Don't forget to like, subscribe, and comment. And I'll catch you next time on Andy's Motorcycle Obsessions. Bye for now.